Earthquakes are powerful natural events that remind us of the dynamic nature of our planet. While they may seem unpredictable, seismologists have uncovered patterns and principles that help to understand how and why they happen. For centuries, people have tried to explain the cause of earthquakes. However, modern science has shown that earthquakes result from tectonic plate movements and the breaking of rock along faults. Earthquakes occur because of the stress that builds up as tectonic plates move. Rocks near faults store this energy, but when the stress exceeds the rock's strength, they break and release the energy as seismic waves. This is known as the dynamic energy balance, where stored energy converts into the motion we feel during an earthquake. Once a fault starts moving, the rupture propagates along the fault like a crack spreading through grass. The speed of extent of this movement determines the earthquake strength. Not all earthquakes are the same. Seismologists have discovered patterns in their behavior. For example, smaller earthquakes are much more common than larger ones, but large earthquakes release the majority of energy. This relationship is part of earthquake scaling relations, where small and large events follow predictable statistical patterns. Moreover, earthquakes often form fractal like clusters along faults, reflecting the anomaly and density of the Earth's crust. Seismologists study specific earthquakes to understand their causes and effects. These case studies provide valuable insights into how earthquakes behave in different environments. Additionally, earthquakes often occur in sequences. A main shock is typically followed by smaller aftershocks and sometimes headed by foreshocks. Understanding these patterns helps in assessing risks following a major earthquakes. Earthquakes can influence each other in fascinating way. Static triggering occurs when an earthquake changes the stress on nearby faults, potentially causing another earthquake. However, these triggered events can sometimes take time, as stress builds slowly until the next fault slips. In other cases, dynamic triggering happens when seismic waves from one earthquake travel a long distance and cause another fault to move. Not all earthquakes are sudden and violent. In some areas, particularly along subduction zones, where one tectonic plate slides another one, slow slip events occur. These events release stress gradually over days, months, or even years without causing much shaking. Other slow events can occur on continental faults. Still, they are harder to detect because they don't produce strong seismic waves. These slow movements happen because the rocks in certain areas are more slippery, allowing gradual motion. The mechanics of earthquake reveal the incredible complexity of our planet.